Hi, welcome to today's talk on work. What are we learning? The definition of work, how to calculate work, and what do we mean by positive and negative work? Work has a different meaning in physics than it does in everyday usage. In physics, work is done only if an object is moved through some displacement by a force. And work will be the force times that displacement. You might be tempted to think of work as force times d, where F is the magnitude of the force acting on the object, and d is the magnitude of the displacement. This only gives the magnitude of the work done on an object when the force is constant and parallel to the displacement. This works in certain cases, but as a general, more sophisticated definition, we might want to use this. Work is force times displacement. The unit that we'll use will be Newton times a meter. That will be a joule. Now, what if the force is not going parallel to the displacement? Well, only the component of the force that is parallel to the displacement will do work. In this case, we will have to find the component of the force that is going parallel to our displacement. In this case, we'll use F cosine theta, where theta is the angle between the direction of the displacement and the force. The work will be F cosine theta times the magnitude of the displacement. Just because there is a force and a displacement does not mean that there will be work done. Let's say if you carry a bucket of water horizontally at a constant velocity. This upward force exerted by your hand on the bucket is perpendicular to the displacement. So it does no work. There's no component of this force parallel to the displacement. This can be seen from our equation in that when the cosine of 90 is introduced here, the cosine of 90 is 0. So in this example, no work is being done by this force. Only force parallel to the displacement does work. Now, work can be either positive or negative, but the positive or negative doesn't tell us about the direction of the work because work is a scalar. Let's say we're lifting a box. The box has two forces on it. We apply a force, and it has the force of gravity or the weight. The part of the force, or F, parallel to our displacement and points in the same direction, the work done by that force is positive. So if we are lifting up on this box, moving it through a displacement, we did positive work on the box. The part of a force, F, parallel to the displacement and points in the opposite direction of the displacement, the work done by the force is negative. So the work done by gravity in our situation where we're lifting this up is negative because it points in the opposite direction of our displacement if we're lifting it up. Let's try a quick check on what we understand. Let's say the gravitational force exerted by the Earth on the moon holds the moon in an orbit around the Earth. Let us assume that the orbit is perfectly circular. The work done by this gravitational force during a 1-week interval in which the moon moves through a displacement in its orbital path is it negative, 0, positive, Or is it not possible to determine with this information given? Take a moment and think about this. To help us think about this, let's take a look at a simulation. Here's a simulation of the moon orbiting the Earth. We have a velocity vector, a force vector for our force of gravity. This path is going slightly elliptical, but it's mostly circular. We can see, especially once we get right about down here, the velocity vector and the force vector are perpendicular, just like we saw in circular motion. The displacement will be, at this moment, in the direction of the velocity vector. So the force of gravity is doing no work on the moon. It is making it accelerate, yes, and making it go in a circular path, but by our definition, it is not doing any work. So the answer is 0. 0 work is being done. Seems kind of weird that we have force going on here and it's doing no work, but if there's no component parallel to the displacement, then 0 work will be done. Let's try to calculate force. Let's say we have a 600 Newton force developed by the braking system of a car to bring it to a rest over a horizontal distance of 8 meters. What work is done by the braking system? First, our sketch. In this case, our force is in the opposite direction of our displacement. Now, our known and unknown. Here's our equation. All right, the work done by the brakes will be negative 4.8 times 10 to the 4 joules. Let's review what we know. Work is a scalar quantity. It is the force times the displacement, but it's the force that is parallel to that displacement. Our units will be joules, which is a Newton times a meter. Remember that only force parallel to the displacement does work. The example that we use was the force that we use to hold up, say, a bucket of water. As we're moving it a horizontal displacement, that force is not doing work because it is perpendicular to the displacement. Now, the part of our force parallel to our displacement and points in the same direction as our displacement, it does positive work. The part of any force parallel to our displacement and points in the opposite direction of our displacement, well, the work done by that force is negative. All right, complete your Cornell notes, rewind, and review as necessary.